Okay, Tuesday, November 30th. We're going to get started with relational database technology and one of my favorite languages that I learned so long ago, SQL. Okay, so if you guys go to the classroom, to the main home screen, down here in, I think I can shrink these. Hey, looky there. Down here under relational databases and SQL, which are not synonymous, but almost. These are the materials for today, if you want to get them downloaded. The first one, this PDF, is just a really good slideshow I nabbed from the University of Kansas that goes over this concept of the R in relational database. What does that mean, and how do you line things up in your tables and columns and rows? So we'll go over that. And there's a couple of quick things I wanted to show you here about the different types of commands, and then we'll actually get started with SQL, which is the language we use to interact with that relational database. So I don't know that we'll get through all of this today before my voice gives out, but we will see how far we get. And then, of course, we've got some hands-on brain teaser queries that you can write. This goes from super elementary to there are people that make their entire career out of working with databases, mostly working with SQL. All right. Any questions or anything before we get rocking on previous?
Hey Don, whatever came of the SQL workbench issues that we were having, I still get an error when I try to open mine up.
And you've tried lately?
Yeah, I tried this morning before class. When I try my connection, it gives me the cannot connect to database server.
Could be a username and password thing.
Right.
I apparently I did a cut and paste error when I sent the passwords out for Colton, at least. Colton, you were able to get in, right?
Yeah, I was.
Okay. So I'll resend that, Dave, and make sure that you've got everybody's got the right username and password. That my buddy put your emails in between, and I tried to make it simpler, but I think I goofed it up. So I'll repost that, and we'll get started with that probably here in the second hour. I've got the screenshots and everything for what that connection looks like, so we'll make sure everybody's going through, and if you're having trouble, we can share screens and we'll work through it.
Okay. All right. Thanks.
Sure thing. Okay, so depending on how you like to follow along, I'm going to bring up this PDF RDBMS design fundamentals and talk a little bit about how databases evolved. But they've been like that for a long time. I got into IT programming, good grief, 33 years ago, and it's still a great big part. I don't know that there are hardly any tools that are still useful, still around, like SQL. I mean, there's some, but this is still a main part of most application development and data analysis. Okay, so database design, this is just going to go through this. It isn't too much of a head scratcher. It just shows you how the tables in a database look a lot like a spreadsheet, pretty much exactly like a spreadsheet, columns and rows. But um, the way you lay them out, the way you design what goes in what table and what column goes in that table and whatnot, is known colloquially as relational database design. So we'll go over that. Database normalization, another term. Okay. Uh, so background and terminology. Yeah, a relational database um, is called that because the relationships between things, between entities, are designed into the structure of the database. Um, like I said, that you'll see when we get there pretty quick here, if you haven't before already. A relational database is a collection of information where the pieces and parts and entities and whatnot and characteristics um, relate to each other. That you don't normally put, I don't know, Audubon bird watching data in the same database as NBA player stats. You know what I mean? They just don't really relate to each other in any way. So those would generally be considered something you'd put in separate databases. But if there's stuff that relates to each other, um, we put that in a database, and there are ways to link them together, either structurally or kind of on the fly when you're working with the data. A primary key is a unique identifier. Um, it can be one column, it can be a combination of columns that uniquely identify the row of data. So that's a primary key. So say you've got employee number, employee ID, that's an easy one. Is the primary key in your main employee table. And you only have one column, say employee ID. A foreign key is is a primary key in another table. And we'll show you how to do it. Like if you had an employee table where you wanted to track what cars employees had registered in the parking garage, you would probably have the employee ID and the car's VIN or its decal ID or something like that as a combined primary key in the employee vehicle table. So that employee ID in the employee vehicle table would be a foreign key. It's the primary key over in the employee ID. That's the whole concept between how these tables get related to each other is by using these key columns. So we will talk about normalization. That's why if you guys remember, beg your pardon, during the Excel lessons when we were talking about pivot tables and pivot tables, you need to use normalized data. That kind of that didn't seem like normalized data when we were looking at like the accounts. Remember that bank accounts, what type of account were opened by what type of employee at what branch, when we were looking at that, they called that normalized data, but I wish they would have used a different term. I think I know what they're saying, but that's not normalized data, as we'll see here in this presentation, to me. So things about designing a database, and I've seen a few folks that are whiz bang at spreadsheets get into a little bit of trouble because they're not up on what we're going over now, relational database design. So how to relate tables together, and then there are types of relationships that we'll go over here. and how that data, how the information you're dealing with relates to each other. Okay, what is an RDBMS? It's there's several things you could say about it that would be true. It is a collection of information organized in tables, which are a simple column and row structure. They're associated to each other through these fields, as we said, called keys. The columns in a relational database, on that third bullet, a set of attributes. You probably heard me calling columns in Excel attributes. Each column is an attribute, like age, hair color, whatever. So you'll see that a table is an entity, and a column is an attribute, and we'll get into that with some examples. Tables are related through common fields designated as primary and foreign keys. Like we said, when you use a primary key in another table, over there it's called a foreign key, and we've got some examples of that, plenty. Okay, and RDBMSs allow us to find, update, delete data quickly and help to ensure accuracy. So I'll make sure I'm not getting ahead of myself here. So an RDBMS, Relational Database Management System, is really a piece of software that that is running frequently all the time. Frequently, it's always up because of applications and web pages and stuff are hitting at it, but not necessarily. But it's software. When it is running, it is like a guardian, a traffic cop. It is what makes the database work. It's what you go through it. You talk to the RDBMS to get to the data, generally using SQL, but there's other ways to get at it. But that's what it is. And it does things for you as a database user, whether you be an analyst or an application developer. It keeps you from, it does permissions, lets you set who can see what data. It can throw an error message if you try to do something that's not allowed, like we were talking about. I used the example of an employee, and you're tracking the cars that an employee has registered that they're allowed to park in the parking garage. Well, if you tried to delete an employee and had not constructed the application or whatever you're using, if you hadn't deleted their cars first, you would be orphaning their car records in that table. So every time an employee left, if you don't use the database's capability of, it's called referential integrity, for example, you can have all this junk orphaned data that's laying out there in your tables. So the database will look for things like that if you use it, if you implement it. So there's all kinds of cool stuff that a database can do. An RDBMS, like Oracle MySQL, we're using MariaDB. But that's what the RDBMS is, really, is that software that's running on the computer that manages the data and all these database objects like tables and indexes and procedures and whatnot. Okay. So if you've heard Oracle is, or it's not anymore. It used to be Oracle. All it was the RDBMS they sold. They sell all kinds of stuff now. But like Oracle, MySQL, SQL Server, Postgres, these are all RDBMSs that all do the same thing, basically. Okay, so that's what an RDBMS is. Primary and foreign key, like we said. Primary key field has to be unique and it cannot be null. Each table should have a primary key field. I, generally speaking, cannot think of an application where you would not have one. That's a great way to get duplicate data and garbage going. So I would highlight should in bold letters. A concatenated key is when you use more than one column or field or attribute. There's those three words are synonymous as the primary key, and you'll see there are times when you especially in a linking situation where you're linking to related things. You have to have a concatenated key. That's really how that's the way it's done. So yeah, and a foreign key are in a table that refer to the primary key over in the other one. And we've got examples in this PDF and in the database that we're working with. Yeah, and the data will be an exact match, a foreign key that whatever the like employee ID in its existence over in the foreign key will be an exact match to the primary key employee ID over in the employee table. Okay, normalization is where it's a kind of an iterative. For folks that have been working with it for a long time, it's just ingrained in your thought processes. But it's actually an iterative process where you look at the data, like you could be just talking to someone in a user experience analysis design role, and as they talk about the data that they use and the way the information is laid out, you would go through the process of normalization to get it into a table structure that is normalized. Okay. And this is, I don't know, 40 years old, this process. But you'll see when we go through here, it eliminates storing data in more tables than you would have to. And if you're working with larger data sets, millions of rows, having a column repeated where you don't need it can add up to processing time and storage space. It ensures data is in the correct table, that the attribute is in the table for the thing that it describes, those sort of things. And it eliminates, once you've got the structure of the database correct, there's very little that you have to do to restructure the database to add something. You might need to add an attribute column, but your core database should be pretty robust as far as new stuff coming in. And that can be a whole new table, or like I said, an additional column when you need it. So there's 5 levels of normal. There's first normal form, they call it, second normal form, and third normal form. And there's fourth and fifth. I think the guy that created SQL, Boyce Codd, has a Boyce Codd normal form. But generally speaking, third normal form is good enough for most, like a web page or an MIS system or a supply chain management system. That third normal form generally gets you there. So we'll show you what that looks like. So this is kind of like a check, almost like a checklist, where you would look at the data and see if you're violating any of these rules, and if you are, you fix it. And then until you get to where you are in third normal form, and then it works. Like this is all kind of theoretical. It works with every database. So I'm going to try not to belabor it, but it is important to understand how these concepts work. So there's no repeating or duplicate fields, first normal form. Each cell contains only a single value. You see that a lot. You see spreadsheets where they've put multiple things in one column, in one cell, that you would have to like break up and substring and, goof around. Each record is unique. So and you've got of course, a primary key is your unique identifier. So we've got some examples of what is first normal form, but then why it's not in the next one, kind of thing. So this table is not in first normal form because, yeah, like I said, you've got like red and blue here. T-shirts are sold in red and blue. Polo shirts are sold in red and yellow. That in and of itself violates third normal form or first normal form. And then here you'll notice row 1 and row 3 are duplicates. They're identical. You've got no primary key to say, like if this was the garment table, you would need like a garment ID as a primary key. So that's a no-no. You can start to look at this stuff, and it's just like I said, if you're working with relational data and SQL, it just becomes pretty intuitive. But there's a theory, there are rules behind it. Okay, so for this one, we would break out T-shirt and color are a concatenated primary key. We've only got one red T-shirt. We've only got one red polo shirt. So there you go. Now the price for it and the tax on that actual item. We'll get to that in a minute. But that puts this table in first normal form, but it's still goofy. Goofy means not in third normal form. How we doing, guys? Can somebody tell me that this is the first time they've actually heard this terminology formally like this? Or has absolutely all of you had this before?
Yeah, this is new to me.
All right, Dave. Good.
I know that's a shocker, but yeah.
Nope. This is when people go from, you've seen it, I'm sure. People go from Excel to Access. I've picked up 2 or 3 databases over the years that when the person created it in Access, they didn't know this stuff, and it just made it hard. You almost had to scrap it, start over again to get the data lined up correctly so that everything works. Okay. So second normal form, all non-key fields depend on all components of the primary key. So this is only applicable really when you have a combination key or a concatenated key. Second normal form you'll always be in second normal form if you have a primary key in one column, like employee ID or something like that. So this one's pretty easy. This table is not in second normal form because price and tax depend on the item, which is a T-shirt. If you'll notice the T-shirt is $12, but a sweatshirt is $25. But you have a blue, so 25 and 12 don't depend on blue; they depend on the item. So that's it doesn't depend on both, which it needs to. Okay, like I said, if we had a garment ID column, it would fix all of this. Okay, so that violates second normal form. So uh, what this does is starts to show you how when you're looking at the data, it just starts to make sense that they break out into different tables because they are separate entities somewhat. And I think we'll get to that by the end here. So a t-shirt, regardless of its color, is $12. But then you've got this garment table over here that it's still kind of goofy. Still kind of goofy. Although they don't repeat, I mean, there's no violation here. There's no t-shirt and red are unique in this item color table, but it's still a little goofy. Okay. Third normal form. All non-key fields depend. All non-key field depends upon another. And all non-key fields depend only on the primary key. That's more clear. Yeah, this second statement here. All non-key fields uh, depend on the primary key. Um, like I said, hair color. There may be, rules for how many different hair colors you can type in there, but for that row, that employee, they only the hair color you pick depends on that employee ID, and that's it. So back into our garment example here, the tables are not in third normal form because the tax here, if you notice, is 5% of the price. So tax depends on price. It doesn't depend on the item, which another term you'll hear is that's derived data. You probably don't want to hard code the amount of tax in here because it's always based on a percentage, or almost always based on a percentage of something else. So you wouldn't want to really store derived data in there. You could store mathematically what the tax rate is, like 0.05, and then change that. But you, generally speaking, you don't want to store data that you can calculate reliably based on rules. But for database design, yeah, tax depends on price, not on item. So that violates third normal form. So we now have 3 tables in the database. We've got a tax table that has a, say it's not a mathematical formula, say it's graduated, or, between $0 and $10 has a certain rate and it changes. And so you could have a tax table like this. And then the price of a shirt, the price of an item depends on the item. And then you've got this, what different varieties of t-shirts and polo shirts and sweatshirts do we have over in our item color table. So that's kind of the rudiments, the fundamental steps you go through when you're looking at data. And I've got a little bit more on that as we move through here. Here's another example. Let's see. It's not in first normal form because, you see this all the time. Yeah, and I'm in the middle of this with ACDS in my normal job because it's a COTS product, and when you add custom fields inside of a COTS product, very often you can add attributes, you can add columns, but you can't create a whole another table, a whole nother repeating thing. And I'm running into this now. So when you have you know, this is spreadsheet thinking, I guess. I don't want to be too derogatory, but this is thinking like Excel without thinking or without knowing about RDBMSs. Um, you've got assignment 1 and assignment 2 for each person. Well, um, it anytime you see a repeating field like that, where you might have to go in and change the structure of the database because now you have a assignment 3, that should be an alarm bell that you're not in third normal form. And you've got full name in your name field, so that's not good. You got more than one piece of information, um, and there is no primary key. So this is as soon as you look at it, it's obviously goofy, to use the technical term. Here we go. Another example. Oh, uh, yeah, pulled this out. So this is where you start to see the primary key, foreign key, and relationships, and how each table is an entity, it's a thing. Now it can be a thing of its own because it's a combination of two things that make that thing unique. So hopefully I'll make that clear here on this chart. So you've got just like you would think, a student ID as your primary key in this bottom left-hand corner, their first name and their last name. So that that looks legit. And in that student, you would call that table probably students or something like that. In there is where you would have any other attribute. You'd add columns as you needed an attribute for each student. You'd add a column for um, home address, date of birth, country of citizenship, whatever you want to ask about that person. And it would all of those columns, all of those attributes would be dependent on the primary key, which makes it third normal form. Now you've got another entity up here in the assignment ID and description. I would call that the assignment table. And assignment ID is your primary key. 1, 2, 3. So for all assignments that you would ever give a student, they all go in this assignment table. So you've got a description field. You could have, whether it's a type of assignment like test or essay or verbal quiz, whatever, anything that describes an assignment in and of itself, maximum number of points, anything that depends on this, this assignment ID 1. What is, anything that just further describes this article summary or this poetry analysis assignment would be additional attributes, additional columns. But then you got to be able to link them together because you have students and you have assignments that a student can have many assignments, right? And an assignment can be assigned to many students. So you've got to have a way to link them together. And this page shows the epiphany, the magic of this third normal form and relational databases, because it might be tempting if you're a spreadsheet user to just keep adding assignment number columns to this student ID table. It's just assignment 1, assignment 2, assignment 3, assignment 4. It's never ending. It's unmanageable. You can't do anything with it. It's terrible. So that's why we made the leap 40 years ago to relational databases. So this is a concatenated key over here, and I would call this the student assignments table, because it tells you which students have which assignments. And then you have 2 foreign keys here. Assignment ID is a foreign key, coming back here to the assignment table, and student ID is a foreign key back here to the primary key in the student table. So these, on this right-hand table, these are both foreign keys, and when you put them together, you now have a primary key. So now that you have this identified, so that student number 1, Jeff Smith, and he was assigned the article summary assignment in this first row. Now you can start to store things like you can add columns to that entity. You can add attributes to the entity that is the assignment and student combination. Like, for example, a student gets an assignment. What is something you might want to know about that combination? Hampton. What's another attribute you might add to that right-hand column?
Did you say my name?
Yes, I did, Hampton. Good morning.
Sorry, I'm in the office today, so it's a little louder than normal. But
Yeah. What's an attribute that you would add to that that table on the right, where you have assignment ID linking with student ID?
are you talking about first name or last name?
Well, you've got first name and last name is over here. You can go look that up because you've got the student ID. You can go look up the last name and first name over here in the student table. But what I was going for is, like, when a student gets an assignment, you may want to know the date that it was assigned.
Oh, okay. You're saying something that's not already on.
Right. What's another attribute? What's a new attribute that you would add to this table on the right?
So it could be like due date or how many points it is.
Due date, what their grade was, what they scored on that assignment. Yeah. Those would be attributes that describe the assignment student relationship. So you could add columns to that. But you'll see this whenever you have a situation where you've got a lot of things like assignments and a lot of other things like students, and they have a many to many. Many students can have many assignments. Assignments can have many students. Whenever you have that many to many mesh like that, you're gonna need a breakout table like we have here to make everything work in third normal form. Okay. So I will keep on. Yep. And relationships. Here we go. That I segued in myself. So relationships are created between the tables using the primary key and a foreign key field. A one-to-one relationship. One record in a table relates to one record in another table. Generally speaking, you don't do 2 tables if you have a one-to-one, and I think that'll become clear. One to many means that one record in a table can relate to many records in another table. For example, our employee car situation. An employee can have multiple cars that are allowed to park in the garage. But for the sake of responsibility and accountability, the business rule is that every car must be related to one employee. So you have one employee to many cars. That's a one-to-many relationship. And then you have what we covered here in that last one. You have many to many relationship where you've got a thing like uh, um, courses and students. You need a way to talk about which student in which course. So that's a many to many relationship. I'll go back to that last screen. Many assignments and many students. So you're going to need some way to model that relationship. Okay, so those are relationships. 3 kinds. Okay, I'm gonna leave that up and I'm gonna put us on break, our first break of the day, till 9:30 cell phone time. Any questions before you go on break? Okay. Well, if anything comes up by the time we come back at 9:30, please slow me down, please. So here we go. Break till 9:30.
Uh, Dr. Walker, if you're speaking, it looks like your mic is on mute.
I am speaking. I've been talking for 5 minutes.
I just started seeing your mouse move and something was highlighted. I was like, oh,
I've
it's on
been
mute.
No, I didn't turn the camera on either. So anyway, let me back up just a little bit. And I was just saying that, yeah, relationships, there's 3 types of them. One-to-one is generally an attribute. You just need to add a column to a table. So then I went down here and so like you've got this arrow going from the item price table, this purple arrow, one to many. I'm sorry, one to one. Every item has one price, so there will only be one row in here that reflects in the other one. But Each price can be used many times because you've got t-shirts and polos that are both $12. So that's your one-to-many relationship. And this is PowerPoint symbology. There's a more formal way to model this, which we will cover. So that's that's an example. Those are examples of one-to-one and one-to-many. Like I said, generally speaking, one-to-one, you'd put another column out there. Okay. There's a one-to-one relationship between a student assignment pairing and that student. So anything you put in that table, this assignment student table, is going to have a one-to-one with student ID. It's also going to have a one-to-one with the assignment ID. But so it is the joiner of the many-to-many. See over here, the dashed gray arrows between assignment ID and student ID. You have many assignments. One assignment can be assigned to many students, and one student can have many assignments. So you've got many to many, a bidirectional many to many relationship that has to be broken out into another table. That's what happens when you identify a many to many relationship. The go-to technique is to create another table. So that's what's reflected in this one. Okay, thank you so much to Dr. Hernandez, Dr. Chappell, Dr. Wise. And then of course we've got more stuff out there, and this is all over the internet, guys. I mean, there's YouTube videos, tutorials. If what I am telling you isn't sinking in, you want to hear it in another way, there's any number of other resources out there, other tutorials for just the concept of normalization and getting those tables lined up. Any question on that so far? All right. So the next file is Death by PowerPoint for this next hour. So I'll put that away. And of course, that is in the classroom in the appropriate section. Okay, so the next one, we're going to go ahead and talk about SQL and make sure that your SQL Workbench application is connected to our database. So yeah, what are we going to study about this, and why SQL and why MySQL? And then these are different types of queries. Everything we're going to do, SQL can do a lot involving the database itself and the data. We're just going to worry about queries. There are other folks that besides, and most analysts aren't really creating database objects. But if your path leads you in that direction, there's any number of resources to teach you more. But we're gonna focus on what's called a select statement, which is how you pull data out of an existing database. So we'll work with one query. We'll figure out how to do those cross table lookups, like we showed in the student and assignment table. They're called joins when you join tables. You can make it's almost like nesting a loop inside of a loop almost, when you can write a query and have some of the requirements. So in the search criteria can be a query itself, which cascades, and we've got good examples of all that stuff. Calculations and single row functions and group functions. So it's a pretty robust language. SQL's got lots and lots and lots of functionality. We'll get to a good bit of it, but definitely won't cover everything. Okay, so why are we studying SQL? Generally, for the most part, the transaction systems that you guys are using are store their data in a relational database, or in some form of database. Not always. Like Colton might be working with a lot of log files that are just text files out on the network. But almost all of your support systems, whether it's a student support system or financial or pretty much any, inventory tracking, any of that kind of stuff, sales, gets stored in one of these RDBMSs or the other. And an analyst often gets to write their own queries against that data to either pull out a data set that looks kind of like a spreadsheet or a CSV, or to actually come up with actual answers to a question that someone has asked you. Who was the top selling salesman in the third quarter of the southern region or whatever. So you write a query up to, it was Joan Johnson, and you can answer that question using a SQL query. So yeah, data analysts need to be able to access databases or their cousins, a data warehouse, to do analytics. Generally speaking, a data warehouse is a place where you pull data from production systems into kind of a safe zone where you can write queries against it and do analysis and run reports and stuff. Generally speaking, so a lot of times, depending on the size of your enterprise, you'll have a whole lot going on out there that you just don't have room or time to mess with. So it won't go into your data warehouse. But as people identify key things that they want to do analytics on, it's safer to pull it into a data warehouse and do your analysis. And a data warehouse can be just another instance of an Oracle or a MySQL database. You develop the data warehouse just like you would develop an application. You design it and get the tables right and everything, but the way you transform and pull data from different places can have a lot of processing involved. Okay, so how do we use SQL and data analytics? Like I said, you can write a query where you pull columns from different tables and all the rows that make sense, and then you can throw those into like Excel and do some charts, or use it in Python to do some visualization. But SQL itself is really only character based. You can't really draw a graph. That's not what it's built for. So a lot of times you'll save the results of a query in something that's more universal, typically a CSV, and then use it in Excel or Python or Power BI. And but some analysts, there's no one size fits all for these roles. They are different roles, but sometimes the same person is responsible for overlapping things that might be a specialty in another organization. Collecting, preparing, cleansing the data. Sometimes you manage the database. A DBA, database administrator, is generally the person that apportions permissions within the database to users and figures out, like a storage space allotted to a given set of tables and those sort of things. Sometimes the analyst is everything. You're it. So it really does depend on your organization. But that's what SQL is for. SQL is the tool, the language, character-based language for working within databases. Sometimes you can do stuff that's click and drag, but generally speaking, a lot, folks use SQL a lot to mess with the data. So 30 however many years later. So these are your primary relational database management systems. Oracle, we're using a variety of MySQL called MariaDB. It's literally a configuration branch. The person behind MariaDB wasn't happy with where they were going with MySQL. It's an open source project. So some years back, he just forked the GitHub repository for MySQL and made MariaDB its own entity, and it's also open source. And eventually, they are getting away from each other a little bit. It's mostly internal, I believe, more than any sort of difference in the syntax of the languages. But that's what we're using. So yeah, Oracle's the big dog. MySQL, SQL Server is Microsoft's version of this. Been around forever. DB2, I think, was IBM. Access is the Microsoft basically single user desktop application, whereas SQL Server is something that can have thousands of users out there, kind of on the internet, that sort of thing. So Microsoft offers two versions of I wouldn't really call Access an RDBMS. It's really more like a relational database application, almost. And then there are other types of databases. Two really common, one is up and coming. Object-oriented database, that is going away. I can't remember the last time anybody mentioned needing to know object-oriented databases, so I wouldn't worry too much about that. But you're seeing a lot more attention being paid to NoSQL databases, which stands for not only SQL. You might have seen MongoDB or be working with it. Do any of you work literally write in Mongo query language or work with MongoDB?
No, we use dbeaver.
Is that also a NoSQL database?
Well, I think it uses Postgre. I'm still learning it. I've never used Postgre or dbeaver, but that's what my company uses.
Okay. Yeah, there are, if you Google like Amazon Web Services NoSQL database. NoSQL is the vendor neutral term for these. MongoDB is a company that sells a NoSQL database, but all the cloud providers have a NoSQL database in the cloud, and the difference between NoSQL and something more structured, Mongo or the other NoSQL databases, those are kind of made for data coming in, and you don't even need to know the structure. Like if you've got XML files that have a key and a value, or JSON files, you can like literally throw them into NoSQL and it kind of figures it out, and you can start to do queries on the data without ever having created tables or anything, because the data itself has kind of like the column name, like name Don Walker, hair color, none. The data is tagged. So these NoSQL databases kind of know what to do with it, and you don't have to create this table structure like you do in relational. But still a whole lot of relational data out there, so we'll continue on with this. But I did want to get a demo from somebody who works with this before we part ways here in February. Okay, now coming up to our database. We use a graphical user interface, a SQL Workbench. My SQL Workbench is a free open source Workbench 8.0. Hopefully you've got it downloaded and installed. If you're having trouble with the connection, we're going to go through that here in the next couple slides. So if you haven't executed Workbench, feel free to go ahead and kick that off. And we've got to connect. I emailed everybody the username and passwords that I got directly from my buddy Justin. So if you haven't checked your email, pull that up and take a look at your username, and maybe you might want to cut and paste your password. So when you get to SQL Workbench, you're going to need a connection. Workbench is like, your Outlook email client, and you can have 2, 3, 4, 5 accounts live with Outlook. Well, same with the Workbench. You can be connected to multiple databases, or you can have connections to multiple databases that you work with. So you need to connect to our database. Now the IP addresses, this slide's a little old. This screenshot, that IP address is no longer valid. We kill the server to avoid security issues in between iterations of this course. But there's a MySQL connection. You click on plus, and you get this connection dialog box. The parameters that we're worried about are username and password, which I emailed you. Dave, you're the one that said you were having an error before, right?
Correct. I just tried it again and it's doing the same thing. But I'm curious about the default schema because I don't have anything in that box. So let me try that. Do I need to type in Northwoods?
You don't. No, you don't need to.
Okay.
A schema is like a set of tables that are all related, almost like you would call it a database. Generally speaking, you want to put all related tables in the same schema. So you don't need to do that. When you go in, you can double click on the schema that you want to work with in Workbench. Dave, could you mind sharing your screen and showing me the error that you're having?
Sure. Let me copy and paste my email. My password again. I did this earlier, so
Okay.
that way it'll save time.
Hey, John, if I have one through work, can I use that login instead, or do I need to use the one you sent?
No, this database is not at your work. It's hosted on Amazon Web Services.
Oh, okay. I have the login through work, so I'll do the one you sent me. Thank you.
Sure. And there's always a chance that if you're on a work computer, that it could be doing port filtering or IP address filtering. So there's always a chance that it.
Can you see my screen?
I do. Okay.
Okay. So this is the first one that I get right here just by clicking on my connection. I don't know. Are you reading that, or do you want me to show you further?
I am. Close that out and click on the wrench.
Yep. And so I go to the wrench and
Oh, there you go. Host name's wrong.
Stand by.
Oh, okay.
Stand
There you
by.
go. Okay.
All right. So all that's there. And then when I go to store and vault where we put in the password, I get the other error. and I've tried clearing it and then putting it back in. But I copy and pasted the password from the email you sent. This right here,
Yeah,
this may be a company thing right here. Reflectone is synonymous with CAE.
it is. Yeah, that's a problem of working of being on a work computer. If you can put in a help desk
A help
ticket.
desk. Yep. Okay.
And I'm at AE also, and I'm also getting the same messages.
Yeah, if you can't connect, it's almost certainly a filtering issue at your company.
Okay.
So
Okay. Well, yeah. So we need to put in a help desk ticket, is what you're saying?
yeah, unless you've got a laptop that you could do this portion with that's connected via Wi-Fi instead of, and it's not actually behind the firewall or something to that effect. Yeah, you've definitely got to put in a help desk ticket. I wonder if did you do a ticket to install Workbench?
Yeah, I'm pretty sure. Yeah, you in the beginning, I'm pretty sure I did all those steps.
Yeah, that
Well, I had to
they should have
because
they should have if there was any chance of a problem, they should have tested it to make sure that you were going to get allowed outside the firewall. So it may be reopening that ticket might be more
that may not have.
more
I'll talk
appropriate.
to. Well, let me talk to one of or I'll talk to our IT guy. Well, he's
Yeah.
not really the IT guy, but the one who liaisons with all them and see.
Okay.
if
And
we can get anything in short term.
Chaz and Andra, do you know them by chance?
Oh yeah. Andra works for me.
Okay. Ask Andra what she did. I can't remember
Yeah.
if she got it solved. Because I had to. There were so many people that were having problems with Workbench. I mean, there were some folks that like their IT folks basically said that's low priority and we can't help you. And I'm like, well, the company agreed to do this training and I produced the software list, months ago. So,
Sure.
so anyway, but we wound up doing quite a few queries on a website called W3 Schools.
Right.
It's way cool. So we'll get through it. But
Well,
that's, yeah.
I'll talk with Justin or Justin Castleman. I'll talk with him today and see if he can. Leela, you're having the same issue, I imagine.
Yes, sir. I'm getting the same as you.
And
Okay.
it could be that, is there a way to work on your computer without like logging into the VPN? That's ringing a
Yeah,
bell.
I can disconnect. Yeah, we can disconnect VPN. You
Disconnect from
think
the yeah, try that.
Okay.
If it works. I'm trying to think of how you shouldn't need any work resources really.
I'm not logged into our VPN and I'm having the same issue, but I'll submit something and get it figured out.
Okay. All right. Well, we'll keep going.
Will we be able to follow along with you without having it pulled up on our personal computer?
Yeah, I'm gonna do everything that we're talking about. And all that I would be asking you to do is basically cut and paste from a PowerPoint slide into Workbench and execute it.
Okay.
So you won't be able to, but we got a couple of days before we're going to do anything hands-on. But yeah, if you
I guess we can watch your recording and go back and do it.
Yeah, true. And like I said, I'm just cutting and pasting these queries out of the PowerPoint. I went through last night and error checked them all. They all seem to be behaving correctly. So you can do the same thing when the time comes.
Okay.
And see the result, of these queries.
Okay, sounds good.
Okay.
Yeah, so I disconnected VPN and now I'm in. So that certainly did fix that issue.
All right. Give that a shot, Leela.
Yeah, I was just about to put in the chat that I disconnected. I think I'm in now. It just says warning, some things may not be compatible for some
Yeah,
reason.
you'll get a warning message about versions of MariaDB and Workbench, and it just proceed anyway. All right. Yay, party time. Party time, SQL style. Okay, let me back on track here. Okay, so you're connected. I got a few more slides to go through here, and then I'll actually bring up Workbench, and we'll get to work. Yeah, SQL. I slip and call it SQL, but the cool kids call it SQL. It's been around forever, been around for 40, 50 years, and it is the command line way to interact with the database. Like I said, there are some GUI tools that will allow you to use, click and drag and drop, whatever. But generally, SQL is the script language that operates from the database to create tables, to create columns, to insert data into a table, and to query, to select data out of the database. 30 or so keywords that allow you to manipulate and view data, and basically every vendor adds functionality, but there's a baseline ANSI standard for it. And yeah, this Boyce Cod, like I said, that the first time I ever heard that was he has a normal form. I don't know. Third normal form is good enough. But there's one of your titans of database history, Boyce Cod. Let's see. The latest ANSI standard is still 2016. And like I said, everybody extends it, and particular, this is data types. Like somebody will say varchar, another person will say character, another vendor will say string. So there are slight differences in the language. I had to port the database that we're connecting to, this North Woods little community college kind of database set, was in Oracle. I had to do some translating data types and whatnot to get it to work in MySQL. But that's what that is. And generally there are, because there's, SQL isn't the only database language out there. There are roles of that SQL takes on: data definition language, data manipulation language. I think there's 4 of them. So another thing that you can do besides queries is to create database objects. You can create an index on a table so that it queries faster, it operates faster. You can create a view, which looks just like a table, but it filters the data so that the view is different than the underlying actual data, and then you can give permissions on them. But just to make sure that we don't have any accidents, you don't have create rights, so on your account, so you shouldn't be able to accidentally create something that you wished you hadn't. So we won't go into creating objects or inserting data. I mean, I'll show you the syntax, but once you've seen select statements and all the different ways you work with a select statement, the other ones are pretty straightforward. Okay. Like I said, yeah, it can be a data definition language, which is where you create a table and actually define things. Data manipulation language is where you can you can update a row and change somebody's car color from whatever, blue to green, so you can update data, you can insert new rows in a table, you can delete rows from the table, and you can view database. That's what we're going to spend all our time on. It's in its DML function, we're going to work on select statements. Okay, and then there's three basic categories of data types, very much like other tools. You've got a string, which can be anything, alphanumeric characters. Then you've got numbers, and then you've got date time data types. So there's basically two types, and this starts to matter for formatting and when you go to filter the data or limit what you're looking at, you kind of need to know the data type. Okay, so you got varchar and character. Some people call that char, but it's not a character, so it's always been char for me, but I think I'm in the minority. Then you've got number data types, integer, fixed, and floating, and you can go from way out on the negative number line and to way out 10 to the 25 in positive numbers. So you can store very, very large numbers in these databases. And then we have date formats, and just like with every other tool, dates are the most error prone to me, or fussy, to get everything formatted right and get the database to recognize what you're inserting, and then when you're doing queries and whatnot, the format of the date is often, it's just twitchy. It's just twitchy. So that is what SQL is and why we care about SQL. So, any questions so far? I take it those of you that have been silent, Paul, Colton, you guys are connected okay?
Yeah.
All good.
All right. Yeah, I know we got that worked out last time, Colton. Okay, so let me close out that PowerPoint and bring up Workbench. Okay. So, did you guys do the default schema? Did that work for you?
I have not had a chance to poke around. I've been doing other SQL things for work.
Yeah, I would bet that would break, because Justin named Northwoods with a capital N, so the instruction said to use lowercase. I was wondering if that would error, but anyway, you don't need to worry about the default schema, because all you got to do is double click on these schemas. Is everybody seeing like this schema D Walker? Are you seeing that?
I do not. In
Yeah,
my navigator, I see management, instance, and performance. I don't see anything about schemas.
Yeah, I'm seeing the same as Paul.
Oh wait, I was on administration tab. If you go down, you can click on schemas tab. I can now see Northwind, but I don't see D Walker.
You can see Northwind and Northwoods.
Yes, and test, but I don't see schema 1, 2, 3, or D Walker.
Huh. Okay. Well, luckily we don't need to worry about that, but I'll ask Justin to check into those permissions. D Walker is one that I created, but I don't know that I shared it. You know what I mean? I don't know that I gave other users permissions to see it. That's just the one that I'm goofing around with that survivor data. Oh yeah, it was I was messing around with some old data. Okay. So anyway, we will be working with Northwoods. So if you click or double click on that one, anything that any table that you type in, it assumes is going to be one of these, and then you got the usual drop down arrow things. So we've got course section, enrollment, faculty, location, student, and term. In our so what, 7 tables in our Northwoods database. There was, hang on just a minute.
Are we supposed to be able to select S_Dob from student?
You should be able to if you've got Northwoods highlighted in bold, like I do in bold.
Yeah, I get error code, no database selected.
I'm going to stop sharing, Paul. Why don't you show me what you got?
Well, my Northwoods is not in bold though. It's like yours is. Is it supposed to be bold?
Yeah, if you double click on Northwoods, that turns it into the default schema.
All right, do you see my screen?
I do.
Okay. And this is the error message I got.
Error code, no database selected. Select default DB to be used by double clicking its name in the schemas list in the sidebar. And you are.
Yeah, I can try re-execute again.
Yeah,
Oh,
get.
all right, there it went.
There it went.
Okay.
Well, there you go. See how good I am?
You just have to complain about things. That's how you fix IT issues.
That's all you have to do is ask me for help and I'll fix it. So yeah, you gotta double click on Northwoods to make it the default, the schema that you're working in. You can select from the non-default schema. If you had a table over in Northwind, you could say Northwind dot table name, but it makes it easier. And generally, most of the stuff you'll be dealing with is going to be within a single schema, I think. So let me go back to sharing my screen. So this is Workbench. Mostly what you're going to want to do is create a tab for executing SQL query. It's this left little icon underneath File. If you want a new, you don't want to get rid of a query that you're working on, and you want multiple tabs to be able to work on queries, you just get a new one. So I still have that that select statement there, but I can go over here and I can type in a different one. And I'm probably getting ahead of myself, but that's all right. And then you always put a semicolon at the end. We'll get to that. And then just like Jupyter Notebook, if you hold Control and hit Enter, you'll execute your query. So yeah, you can have more than one query that you're editing on a separate tab. Each one, as you're dealing with it, it's going to ask you if you want to save it, almost like it's a program that you could save in a script file, a .SQL file. I don't generally do any of those sort of things. But where are we at here? We just did getting started with SQL, right? We did that number 1, 1014. So the next one we'll go into is number 2. If you download that, we'll get into this in the next hour. But that's pretty much so. So if you're in here, type select asterisk, which is a wildcard for everything. So every column from a table name. So like star from table basically means give me everything in that table, and then semicolon at the end. And then if you just hit the lightning bolt or control enter, it'll run that. And that's all you really need for today's is a way to cut and paste stuff out of that PowerPoint show number 2, rather than typing it all in. And although eventually you'll be typing it all in. So that's where we're at. We'll come back at 10:30 and start writing some queries. Okay. Break till 10:30. All right, hour 3. Single table queries. This is the simplest simplest SQL there is. So we found out last time that we're all connected to the Northwoods schema. I'm not sharing my screen yet. But I am recording. Yes, I am. How's my audio?
Loud and clear.
Loud and clear. You know, story of my life. I've been this way my whole life. Loud and clear. Okay. Northwood schema. So I made a note to myself, Don, show everybody the ERD and the database creation script. So in the classroom, you have a PDF called the Northwoods ERD. That stands for Entity Relationship Diagram. And I'll go over that here briefly. Open with somehow Windows associated PDF with Chrome instead of Acrobat Reader on my machine, and I'm too lazy to go back and fix it. So this is the ERD that was given to me by my good colleague at the College of Business at UCA for these 7 tables for this database. It's a small, very small sample database from a fictitious university. But it's a great size to just kind of get to know some of these SQL constructs. So this entity relationship diagram uses more formal relationship symbology, which I will go over on the PowerPoint because it's bigger. But each one of these blocks is a table. And in relational database design speak, a table is an entity. It's a thing. And an entity has attributes. Attributes are the columns of that. Each row, is an instance of that entity, I guess would be a way to put that. So in our database, we have our primary tables is the student table, at least as far as the number of columns and whatnot. But you'll notice we have some symbology here that is good to get to know. For example, look at the symbol. Well, I'm getting ahead of myself. Look at the enrollment entity, the enrollment table. It in the left-hand column, it gives you information about about the table, about the columns. Like PK means that this is part of the primary key. If more than one are listed as PK, it means it's a concatenated combination primary key. So enrollment is an instance where a student and a course section come together. So a student is enrolled in one course section, and then the only attribute we have of that is their grade in the enrollment table. So that's where, like over here in the upper right corner of the course table, the primary key is the course ID, and then you have four four attributes, and one of them is a foreign key in another table, which I gotta say is course ID. So it's kind of like it loops back on itself. It refers back onto itself. Foreign key here, I'm pretty sure, is this course ID, where it's the prerequisite course. And then you've got courses, you've got students. Students are enrolled in a course section, which is a particular offering of a course. And these little arrows that look like stick figures and octopuses and whatnot, those tell you the relationship, whether it's one-to-one, one to many, or many to many. So that's what's going on with an entity relationship diagram. It tells you the table names in your database. It tells you the columns in your database, and the data type in that third column, that right-hand column, tells you the data type of that column. All it's really missing, all the ERD is really missing, is a description of each column that's more like a data dictionary that tells you what those things mean. So an ERD is pretty essential to be able to work within a database and figure out how to link things together and get the column names right and everything. The column names are course sensitive or case sensitive, so you got to make sure you know the exact column names. Then down here we've got faculty members, and you'll notice like the faculty ID is the primary key in faculty. It's a foreign key up here in the student table, and that represents the student's advisor, who is their faculty advisor. So instead of putting all the information about the advisor in the student table, you just go look up what you need in the faculty table. And then we've got buildings and rooms that course sections will be using. So you've got a relationship between the location of the course and the course section, because of course, different sections could be in different meeting places. And you've got a relationship between the course section and the assigned faculty member that's teaching that section. So this, an entity relationship diagram shows you how the tables and columns are lined up, and how the primary keys and foreign keys relate to each other, so that you can link things together correctly. And we've got good examples of all that if it's clear as mud. So you'll probably want to keep that handy for any time that you're doing, like I got some sample problems. You'll probably want to keep this handy, or you can just go into Workbench and kind of look at you can, if you don't remember the column names in the course table, you can go to Workbench and there they are. And Workbench is smart enough to kind of start doing that autofill thing, kind of like Jupyter Notebook. It's a pretty smart, it's kind of like an IDE really for SQL, integrated development environment. All right, back to death by PowerPoint. So there's the, oh, no, I got to show you the creation script. So there was the ERD. You're going to want to keep that handy. In fact, I'll just minimize that. And the other thing was the database creation script. And this, I just wanted to show you that SQL is not just about querying. I got a text file here. Northwoods for MySQL. What did I do with it? What did I do with the Northwoods for SQL? There it is. Northwoods for MySQL. Okay, so like I was saying, SQL structured query language is what it's called, and that's arguably its primary function. But it will also create these tables and insert the data into them. So this is what a table creation statement looks like. Apologize if that's really small. But you just say create table and then the name of the table. And then you start listing column names and their data type. Column name, data type, comma. Column name, data type, comma. And then at the end of the creation, you can, of the columns, then you can start telling the database to enforce certain rules, and that it can be really complicated. I believe the only constraints I have here are identifying primary keys and foreign keys. But you can constrain the data that goes into the table. There's a lot of stuff you can do so that the database is watching out for you. The database is tending to what's going on with the database. It's not something that you have to program in necessarily. So it kind of automates the erroring. Like here's one, like check to see that status is open or closed. If you tried to say, jingle bells, it would error. It would give you an error because you violated a constraint of the database. So that's what creates look like. Create tables, and you can delete a table by just saying drop table enrollment, and it'll delete it. And then to insert values, you just you put the value, comma, value for however many columns you have in that table. One insert statement will throw a row into the database. So we have all these insert into location values. So this is inserting each one of these inserts a row into the values or to the location table. There's our faculty data, and there's our student data, and so on. So SQL absolutely does this stuff too. There you go. And then commit means save the changes. There's a rollback command to undo, stuff that you might have just done to the database. So there's, like I said, about 30 different keywords like select and insert and update. There's about 30 different keywords that allow you to do stuff, tell the database to do stuff. So that is the way that the data was created in Northwoods. I just ran it. I just opened that and executed the entire file, and because I troubleshot it last time. Where were we? Okay, the Northwoods schema. Okay, so here is the basic syntax for retrieving data from a single table in SQL. You'll notice select, from, and where. Kind of the reserved words of the language are capitalized. In MySQL, you don't have to have them capitalized, but just like going back to our discussion about Python and programming conventions, just generally speaking, folks capitalize the reserved words and then use either all lowercase or maybe camel case, where you put the first letter of each word in a column name is capital and the rest are lowercase. Whatever your organization specifies, though. This is the basic syntax. Now, of course, this is a boilerplate example. This will not run. We don't have a table name. So if you cut and paste this in, you're going to get a big fat error message. The where clause is a search constraint. So select field name, which is actually just column name, comes first. So you select from 1 to however many columns, and those will be output. The columns that you put in your select statement will be output, like to the screen, or that you could save as headers to a CSV file, that sort of thing. So that's what goes on the first line, select. And on the next, not necessarily the next line, but the next clause in your query needs to be your from statement. And that's where you list, we're starting off with one table, but that's where you list the tables from which the columns are selected. And then if you need it, you can add a search condition or a filtering condition using the keyword where. So you select, say, select name from personnel where employee ID equals 105. So it's very English, very intuitive, but it is, it is sensitive to any sort of spelling errors and that sort of thing. But it's very, very, I think, English-like and intuitive. So that's the basic syntax of a basic SQL select statement. Okay, so this should run. I believe I error checked all of these. So you should be able to, if you've got this PowerPoint up, you should be able to just highlight that, Control C, go over to Workbench into a query tab, Control V, and then Control Enter, and your output should be coming out in the by default in the middle block there. Everybody set up that way? Is that what's coming out for you, Dave?
Well, I didn't have the PowerPoint open. I was using yours, so but the first one worked. The first example you gave me, so I have to assume it would work.
Okay. And you're seeing in your Workbench, you're seeing the output in the middle there.
Yes, I am. Yeah, absolutely.
Yeah, that middle window, the top window is your query. This middle window is the output. And you can see going across the top, you got S_first. That's the actual column name from the table. S_first, S_mi, S_last, GPA. Those are the columns you selected. So that's what comes out in your output. And we selected it from the student table. If you leave that out, it doesn't know what you're looking for. So those are the bare minimum requirements. Although I want to say, let's goof around with this a little bit. You can leave out the table and it selects it from the ether, it seems like. No, there's something you can do with the from clause that, anyway, I'm getting off script. So that's your absolute basic query. But if you want to just select all columns and all records, you say select star, which is a wildcard, meaning everything. Select star from, and this example uses the location table. So we say select star from location, you'll get every column and every row. Control Enter. So there we got 4 columns and 13 rows returned. That these little status messages in the bottom window can be pretty handy. That's where if you have an error down in this this bottom output window is where you get like log file errors and whatnot. I was thinking there was a way to resize that, but I'm having trouble seeing it right now. Ah, there it is. Bigger or smaller. So you can slide these around if you don't need all this real estate for the query itself, you can slide that up. Size that up. Okay. So yeah, 13 rows returned. That's always a good sign down here in the in the status output. Anytime you hit a query, tells you how long it took to run and what the results were. So that's the star is every column. So your select clause filters what columns you want to look at. Your where clause filters the rows. And we'll get into that here in just a sec. Retrieving data from suppressing duplicate rows. So we'll see here. Let's run this. And you'll see we get another convention, guys, is the select from where these major clauses in your query. Select from where, order by, group by. There's each one of those traditionally goes on its own line. It just makes it more readable, and that's just kind of the convention. You can put these on their own line. For example, if I say select star from location, and now if I hit return, it's going to say this. It's going to do the same thing, but for readability's sake, it won't error, but for readability's sake, we put them on separate lines. And also, I wanted to show you that the keywords they don't have to be uppercase. That's a convention, but particularly for this course, so that I can read stuff, if you would, use all caps for your major clauses and put them on their own line. Now, where were we? Select star from location. No, select F rank from faculty. Select F rank from faculty will show you that. Control enter. We have, if you weren't aware, in higher education, you have rankings of your professors where, the higher the rank they are, the longer you got to wait for them to show up. So you've got a couple of duplicates here. You got a couple of full professors, a couple of associate professors. So there is a way to only get unique values, and that keyword is distinct. So we type in select distinct F rank, faculty rank from faculty. And again, there, that's normally what we do. So now you'll see that we only got one of each: full, associate, assistant, and instructor. There's your distinct keyword. That comes in handy a lot. Got that there. So by default, with no where clause, it'll pull every record in the table by default. But that where keyword is how you tell the database only to pull certain records. Remember, if you want columns, you just don't select them. You don't have to select all the columns, and you don't have to return all the rows. You limit that by the select clause and the where clause. So where condition is really magical and powerful. So there's two types. There's exact match, and inexact, and there's another keyword we'll go into here in a minute that's inexact, like called like. So here we have some criteria. So I think, like I said, you might find in these PowerPoints, if you get an error message, it's almost always these double quotes. When you type them in, for whatever reason, it's not the right double quote. I don't know what ASCII or whatever, I don't know. But so I wind up having to cut and paste this correct double quote out of PowerPoint into MySQL. But I think I got them all corrected for you guys. So here we're selecting 4 columns from faculty, but we only want the associate professors. So we'll cut and paste that in there. And the Workbench is also nice enough that if you goof something up, you'll start to get errors. So just see how this looks clean and green, and there's a nice little blue dot, meaning good to go. If I mess something up, it will, like if I misspell the table faculty, I think it will start to, no, that didn't mess up. But I know if it yeah, so you get that little red X, it starts to show you where you've got something goofy going on. So if I put the E back, it, before you even run it, Workbench will kind of tell you that there's something suspect going on. So here we go. So this just pulls up the associate professors. Control Enter. So we have Dr. Cox and Dr. Brown are associate professors. And you can have multiple criteria using the and keyword. And generally speaking, those go on separate lines. Just makes it nice and readable. Everybody knows what you're doing. So we'll type those in. So now we're pulling the rooms from the location, beg your pardon, from the location table, where the building code column equals bus for College of Business, and the capacity is greater than 40, greater than or equal to 40. And you'll notice a varchar variable is in quotes, and a numeric capacity is in numeric field. So it's not in quotes. It's like just like you would in a Python or an Excel formula. Strings go in quotes. Numeric literals do not. So we'll hit Control Enter on that one. So room 105 and room 211 are the only 2 rooms where the building code equals bus and the capacity is greater than 40. So we can check that. Kind of, start from location. I'm just going through and I'm going to delete everything. So 105 and 211. $105 is right here. Yep. Capacity is 35. And what was the other one? 211? That looks right. Because there's a 105 in the College of Business and there's a 105 in CR, but they're different room numbers because they're in different buildings. So you can kind of go in and, sanity check or error check your queries by pulling up all the data and just looking at the data yourself and seeing what you think the query ought to return. All right. Isn't this the most entertaining thing you've ever learned in your life? Someone tell me how great this is. Anyone? Isn't SQL the greatest thing on earth?
Oh yeah, I
Phenomenal.
love SQL, except for when it's not normalized.
There you go. When the garbage data makes queries just impossible to deal with. Okay. All right. So these are where you limit the rows that you're returning. Criteria. You can also find null values in the database. Sometimes you want to know where something is null or is not null, and those are keywords. It's not an equal sign, as we have in the next one. So these are, for example, where the grade in the enrollment table is null. No grade has been assigned. So we use keywords. So for those students and course sections, no grade has been in. So yeah, you're null under grade here. But if you accidentally do this, select star from enrollment where grade equals null. So it happens here. Kind of goofy. No rows. Equals null is not the same as is null. Is null returns rows where it is null. Equals null is looking, I think, for maybe like an operator or a variable called null, and there isn't one, so it just returns nothing. So just remember that it's is null. Okay. Or is not null. So this is where you're, affirmatively pulling up everybody that has a grade assigned. Okay. And then more working with the where clause. There's an in operator that's a lot like Python, where it checks to see if something is in a list. So you can say select star from enrollment, where grade is in any of these, A or B, and then you'd list however many things meet your criteria, and you can add that. Woo! Excuse me. You can thank you. Let's add a C here and see what happens. A, B, C. So that brings up to C. So there you go. So if you have a list of values that you want to see if the grade in, or you can say not in. Everybody got an A, B, or a C. That is just ridiculous. Let's see the B and C students. This should be just the A students then. Bam, there you go. So in and not in, or how you check to see if something's in a list or not. Pretty English-like, I think it's, but it gets really complicated. I mean, just pages in one query. Like I've seen queries that were 2-3 pages of joining tables and where clauses and just complicated. So you can make a career out of this language. The like keyword looks within a string. You generally speaking, you use you use it as with a wild card character generally. So yeah, typically uses wildcards. The percent wildcard is nothing to however many characters. An underscore is one and only one character. So it can be any one character, but it can't be more than, more than one. So we've got a few examples of that. So this will find return any row where term description starts with anything but ends with 2006. So the final four characters would have to be 2006, but they can be preceded by anything because we have the percent sign. And I believe we've got some examples of that. So select everything from term, where term description is like anything 2006. Control enter, bam. So spring 2006, summer 2006, fall 2006. There you go. Or if it starts with fall and ends with anything. Now, okay. Does capitalizing matter? I want to say no, but let's try it. Because the literal in the data is capital F, which I think we already had there. Yep. So that brings back fall 05 and fall 06. And the only difference here is lowercase f. So if we drop that to lowercase, I'm thinking it should return nothing because it should be case specific, but it's not. I guess we'll get to that. More later. First character. And this one, if you put the percent on both ends, it returns anything that has the word systems anywhere in it. Actually, that should be an S right there. Systems. So we were missing an S there. So if you put the percent on both ends, it can be anywhere in that string and match. And yeah, the underscore is a single character. But the second character must be an R. Underscore R. Or S class like underscore R means that S class it returns rows where the second character is R, but it can only be. There you go. Okay, so select call ID from course, where call ID like percent, and if you cut and paste this, it should work. It's 2 underscores, percent anything 1 blank blank. So we'll run that. So 1 and the blank blank is 5 5, and MIS 1 and the blank blank is 0 1. So that's how you combine wildcard operators. Okay. And just like you'd think, you can use less than, greater than, equal mathematical operators when you're dealing with numeric columns. So we'll look at all the faculty members making more than 50K, which is really all of them. So that just looks at the salary field, make sure that it's greater than 50K. And we can use less than or equal to in math, just like you would think. Just like you'd think. Very intuitive. But you know, look like this query I want to show you. We're selecting last name and GPA, but we don't have to select GPA, even though it's in the where clause. It still works kind of like just like you're reading it. Select the S underscore last, which is the student's last name, from student, where GPA is less than 2.5. That will go through. It'll still go through each row, and it'll check that where clause and only spit back rows that meet that criteria. But it'll only display the columns that you put up here. It doesn't have to be in the where clause. Okay. Because sometimes you don't want to see the GPA, you just want to see the last name. But that shows you that one there. Just want to make sure I may be getting ahead of myself, but I wanted to make sure that's clear. Does not have to be in the select clause to be in the where clause. And then you can sort. Now the database itself does not necessarily store data in any particular order. So to depend on sorted data, we have yet another keyword, order by. You specify the order. So we're starting to get where our select statement's starting to build up and get pretty powerful here. So we have select the column names we want from which table name, where, and we can do, you know, one search condition, multiple search conditions. And then we want to sort it order by, and then that's going to be a particular column. And the sort key field doesn't have to be in the select statement. Doesn't have to be in the where clause, but it will sort those columns, whether you're displaying it or not, by the column that you put in your order by. The sort key field can be any field within the select clause, depending on the data type. These are defaults. Now, did I misspeak? We'll see. I might have just sold y'all a bill of goods. We'll find out here in a minute. I was thinking the order by does not have to be in the select clause, but Jim's pretty smart here. We'll see if that holds water. The select field can be any field within the select clause. We'll see. All right. And by default, it goes low to high, not numeric and alphabetically. Low to high, old to new by default, but you can reverse that by telling it desk for descending. So that'll reverse that. So we've got a couple of examples here. So we want to select 3 columns from location. Yeah, I'll use this to test. Go back over here. Okay, so we're selecting building code, room, and the capacity, which is number of seats, from the location table where capacity is greater than or equal to 50, ordering by the capacity. So we'll do that. So it's 55 and 150. But I want to see something here real quick. I want to see if I leave out capacity from my displayed columns, what will happen? Yeah, that works. It doesn't have to be in the select statement. Capacity column does not have to be one of the selected or displayed columns to be used in the where clause or the order by clause. It reads them into memory and does the order by, but it only shows you what's in the select statement. All right, and you can change that to maybe 30 and get a few more rows. And if you leave out the order by, here we got, 35, 40, 42, 55, 150. It sorted it ascending by capacity like you would think. But if we leave that out, we'll look at what is just raw in the database, however it happens to be storing it. And yeah, it's all over the place. 150, 40, 35, back up to 42, back down to 35, back up to 55. So that's why you need the order by, because you never know how it's going to come out. Or we can change it to descending. Let's say greater than 40. Get a few more rows. 150, 55, 42, 40, descending order. And they need to go in this order. If you goofed up the where and the order by, you'll get an error message. So those clauses need to be in that order, and you kind of get used to where they go. Select from, where, order by. There's a few others that we'll go over. How we doing, guys? Thumbs up, thumbs up, thumbs up. Okay, rolling. All right. Did we lose some folks, or is it just my display? We're missing Jim and Regina. Oh, good to go. Okay, guys, back around to break time. Got the rest of this one, and I think we'll get a little bit into the next one. Actually, no, that's a good time to break. I'm just going to finish, guys, and we'll break for the day. Finish out this one, because the next one is where you start to link tables, and it gets a little dicier. So I'm just going to finish out here. So hang with me. We'll be done in about 5-10 minutes. Okay. So that's sorting. Sormatting. Sormatting is the combination of sorting and formatting, by the way. Okay. So formatting our output, which I always hate it, but there's a few ways to do things in SQL. When I started with SQL back in the old days, we came across the Rocky Mountains in a wagon. We were writing our queries in the buckboard. And when I started with Oracle in '88, SQL was a reporting language. You could write these select statements, and there were formatting keywords that let you do stuff like turn on or turn off, whether there was a dashed line underneath your headers. You could set up subtotals and all kinds of stuff. So you could actually write a report, a tabular report, in SQL as a kind of as a scripting language. But folks are kind of getting away from that now. But there's still some stuff that you might want to do, particularly if you're creating a CSV, you might not want to necessarily use the original column names. So you might want to put an alias for a column name, which is easy enough to do. You just select field name 1 in this example is a column. And then in quotes, you put heading text. So this basically renames the column. And you can do that for however many columns you want. So we're going to create, for practice here, I'm not going to hit next slide. We're going to create a query on the location table that changes the column names of building code, room, and capacity. The query should display all rooms where capacity is greater than 30 sorted by capacity size. Okay. So I'm going to go over to Workbench and I'm going to create a query that changes the column name, building code, room, and capacity. Okay. What? Oh, look at that. We got something right here. Started. So I'm going to start from scratch. Okay. From scratch, from the top. Select in all caps. What the heck did we say? Building code, room, and capacity. And we want that to be called building. So we put that in quotes. And then we want room, which we're calling room number. So I put that in double quotes, room number, and then capacity, which we were calling something really creative. Oh yeah, capacity with a capital, because if you don't use an alias, it won't change. So that is everything you need to put an alias on all of those column names. But we got to tell it what table, right? Use the location table. So we come down here to the next line and we say from location. Whoop. Yeah, location. That's right. That doesn't look right. Why is from not highlighted in blue? There's something going on with capacity up here.
Do you need a close
Do you need
location?
another quote and room number? Or-
I missed my column.
oh, there you go.
And I missed my quote in. I'm making mistakes all over the place here. Who hired this guy? Good grief. From location. There, but that shows you pretty slick, right? I mean, that before you even hit go, it's highlighting stuff that it sees as suspicious. That's the application. That's not the database doing that for you. That is Workbench in tandem with the database. Okay, and the query should display all rooms where capacity is greater than 30 sorted by capacity. Okay, so we need a where clause. And you see how it auto, if I hit tab, I think bam, it auto fills when that little menu comes up, where capacity is greater than or equal? Greater than 30. And then we say, what do we say sorted by? Everybody's on mute. Now it plugs it in as lowercase if you hit tab. That's that'll just drive some folks nuts. Order by capacity. And then of course we need a semicolon at the end. Does that look right? Something ain't right. Unknown column.
Capacity is
Cap
spelled wrong.
City.
Order capacity is spelled wrong.
Unknown. Cat. It doesn't know what it doesn't speak Wimtran. Capacity. There we go. Normally, did it red underline? It did not. Normally, it kind of tells you something's goofy there. All right, there we go. Got to spell it right, and it's case sensitive. If I said order by uppercase capacity, no way. Oh, because I've given it that alias up here. You can use I want to say you can use the alias in your where clause and in your order by clause. If we call this the location table with a capital L, I want to say it'll choke. Bam. Northwoods dot capital L location does not exist. Got that down in our error output window. So the objects are case sensitive, but let's see. I want to see something here. Select building code. So what's our output here? Let's say order by. It seems like you can use the. Seems like you can use the alias. I'm going to test that. Getting ahead of myself here. No, not liking that. I want to say. Nope, that didn't work. There's a way to use the alias, but I'm trying to remember. I'm going off script. Anyway, order by capacity. What is going on here? I got a comma in there where I don't. That was an interesting happy accident. I had a comma between the column and my my alias, so it selected the string literal. There we go. But you can select a string literal, and it comes out just like it's a column. It's okay with that fact. Like, isn't that crazy? If you needed that for some reason, you can just select a string literal. And it puts it out there for you. All right. Where are we at here? Oh, yeah. So if you just want to cut and paste what I did, there it is on the final slide. Okay. Single table queries. You'd limit the columns you want to see by putting them in your select clause, and you only use the ones that you want to see or that you want to. You see this little export button here. You can save the column name, the column headers, and the data. You could save that as a CSV right here from Workbench if you so chose. But that's how you limit the columns by putting them in your select clause, and then you limit the rows out of your database by putting search criteria in your where clause. You sort them with the order by. That's the basic building blocks of a SQL query. There's a lot more to it, but that's your basic building blocks. Any questions or concerns?
Yeah, Dawn, would you mind to stay on a couple minutes with me after you're finished and see if you can point out anything I'm doing wrong to log on?
Sure, absolutely. And if
you.
anybody else wants to stay on and and look at Python, if you're having trouble with the that Python exercise too, we can stay online and do that. But that's all I got for new material today. So I'm going to stop recording and wish you all a happy Tuesday. We'll see you Thursday morning at 8:30.
Thanks. Take care.